We did get one more person in, but anyway, we'll start. A little bit about me. My name's Andy Benson. I've been working at Bytespeed for almost 10 years now. I started building actually, and kind of worked through a couple different departments. Eventually hit server team and network administrator about 7 years ago. I am Juniper certified and have experience deploying and assisting hospitals, schools, government agencies, working with the county right now in South Dakota, actually deploying networks and new switches, redesigning their networks kind of a little bit on the fly, and firewalls, switches, routers, access points. So I got some experience doing a little bit of kind of everything on the network and a little bit of everything at Bytespeed, and at least in the production side. So that's a little bit about me. This will be kind of some basic concepts that I think are good to know, and a good starting basis on designing a network. Basically, kind of don't want to overly complicate things, because it's going to make things harder in the long run. One of the hospitals I worked with had by the time we replaced or worked with them to replace their firewall, it probably had like 15 different people work on it, and so it gotten bloated and overly complex. So kind of want to work with making it kind of simple, something that makes sense to you, something that's not overly complicated, just so it's easy to manage. With that, like I said, want it to be easy to manage, and usually with that ease of management, you get, in addition, ease of scalability, reliability, and security. If you have some downtime, that costs money. So we want something that is going to be reliable. And we can use different types of switches, different types of layer 2 versus layer 3 technologies to actually do that. Oops. Okay, I'm sorry. I just want to make sure I was screen sharing. For example, we can use a leg group. If you're from the Juniper world, a trunk if you're from the HP world. So a link aggregate group to combine multiple ports into layer 2 redundancy, and you can use that between switches, servers, routers, other networking gear. You can use STP or spanning tree protocol to reduce the probability of a loop. If you get that loop, basically you get a broadcast storm. All of your packets go everywhere because the switches don't know where to go, and that will slowly take down your network. Depending on certain things, it could be right away, could be a little slower. One example that I like to use is that we had a customer, and she upgraded her wireless upgraded her switching, and she went from 100 meg to a gig everywhere with a 10 gig backbone. And once she did that, there was some dumb switch somewhere that had a loop, and that caused enough of a broadcast storm to not take down her network, but enough to make her wireless just slow down to a crawl. So you can use some layer 2 technologies to prevent some of that. And you can also technically use spanning tree to do some of that redundancy as well. It It is an older technology, so if you do have use spanning tree for redundant connections, basically one connection is going to be shut down until another connection fails, and that redundant connection will turn back on. It will converge depending on how fast your timers are. There are also other layer 3 technologies, so routed technologies that can add redundancy, such as OSPF or EIGRP. An example I like to use is my old boss, or my current boss, sorry. He used to work at a school down in Iowa. Each building, he had about 8 different schools. Each building was their own layer 3 broadcast domain. He had a core in each building, and those were all connected by a fiber in a whole loop. And he had Cisco switches, so he used EIGRP, and he had 2 entrance points for or exit points into the internet. And so if somebody cut a fiber, which he said happened way too often than it should have happened, buildings that were behind each other, quote unquote, and behind that cut fiber didn't go down, because they just ended up routing the data and traffic to the internet in a different way, by a different path. With all that said, again, I don't want a network that is too complex. I've been through that process on trying to get something upgraded. It's quite a hassle, quite a lot of stress, trying to kind of upgrade a network that is overly complex, that has been not necessarily, maybe it didn't start this way, but people added on different tech directors, different techs. We kind of want to keep it simple. It's just easier to manage. There are tools to help with that. And then generally, if, again, in my mind, if it's a little easier to manage, a little easier to secure. Okay, sorry about that. I had to go let my dog in. Okay, so there's kind of 2 types of switches out there in my mind. There are kind of layer 2 switches. These were, this is essentially what the first generation of switches were. They allowed us to switch from pretty much hubs, which would take and bridges, would take one packet and then just broadcast it pretty much everywhere, to individual connections to each device. And technically there is just one quote unquote broadcast domain between the switch and the device. But if you're broadcasting in layer 3, that does still get broadcasted across the rest of the network. So they move packets based on the MAC address of your network card. They aren't very smart. I'd call them dumb switches. They get usually no configuration to them, but they work. They don't care of anything above layer 2. So you can send pretty much anything that you want through it, whether it's got a VLAN tag or not. It basically takes that MAC address, it takes that packet, sees the destination MAC address, broadcasts it out. If it doesn't have it in its switching table, it'll broadcast that packet to every single port, find out what MAC address or what port that MAC address comes back through, kind of listens to the conversation, finds out what port that is, and then it starts sending traffic directly from your computer to your firewall. Again, it doesn't care on what VLAN it's on, virtual LAN, which we'll kind of discuss a tish later. It literally opens the packet up essentially to the MAC address and then goes on with that. Then they started to come out with quote unquote smarter switches. layer 3 switches, they depending on how smart your switch is, you can get a switch that is configurable, still doesn't route anything. It would be kind of like a layer 2 smart switch. It allows you to enable or starts to allow you to use that VLAN feature where you can actually set up ports where basically set up as an access port, and an access port will only allow untagged traffic inbound, and it will drop tagged traffic. So a virtual LAN is that's part of a virtual LAN, and a virtual LAN is I like to imagine it as separate physical switches, even though it's all kind of virtual. They're separate physical switches, and you cannot communicate between those switches. And the way that it's handled internally, but the way that you can do that and make sure your packets make it to the right VLAN on a different switch is there's a in part of the header of the packet there's a tag. It's a VLAN tag, and it's just a little ID. Basically 1 through 4096, and you can set up your ports to read that tag and then decide what to do with it. So ports that don't read that tag or will drop everything else that does have a tag is called an access port, and it can be a tish more secure, just because you know that switch is not going to be broadcasting every packet it receives to try to figure out where to go. It knows that, hey, this data coming in this port is supposed to be on this VLAN. Or with phones, you know, a lot of VoIP phones, you can plug your computer directly into the back of the phone, and the phone goes into the wall. Sometimes it's a good idea to put those phones on a separate VLAN, and so that port that you're connected to is technically called a trunk port, where it'll accept untagged packets. It'll put it in a particular VLAN for your data traffic, and then for your voice traffic, those packets will come tagged from your phone. It'll accept those packets and put those packets in your tagged VLAN, your VoIP VLAN, and then if you connect something up and you send any other VLAN or any other packet that's got a different VLAN tag on it, you can configure that port to either accept it or you can drop it. Then you kind of have true layer 3 switches where they actually do route. Again, they still switch kind of like the layer 2. They are, you can start using access control lists, or in the Juniper world, they're called firewall filters, to start controlling where your data is allowed to go. Some switches do allow you to do layer 2 access list firewall filters, and then there are extra kind of layer 2 MAC address security that you can do on top of it. But kind of the quote unquote smartest switches do pretty much all of that, and then allow you to make them a router. And that's what we do at Bytespeed. We have a firewall. That's what a lot of places do, actually. They have a firewall that routes data to the internet. Firewalls, make sure no data is coming in. Maybe it does antivirus intrusion detection, and then internally, all of the internal traffic is routed on a switch, or maybe even a separate router. To pull the load off the firewall, you can just dedicate that firewall just to getting traffic going to and from the internet, and then your firewall and router know of each other and connect and send the route data as needed. Okay, so kind of a basic layer 2 example here. Again, we have that dedicated firewall / router coming in. We then have our switches in building A, and in building B, we don't have any additional internet inbound. We just have a direct, safe 1 gig fiber network between the two. This is pretty simple. but it kind of gets the point across. First thing is that if you're, it's easy. This would be really easy to manage. Say one feature with quote unquote smarter switches is that you can stack the switches. So say you don't have individual switches like this. Say you have a stack. So you have 2 stacks of switches, and it adds ease of management. You can you can control it via one management port or point. Sorry. So it simplifies management, but you still got the 1 gig fiber link between the two. It is easy to manage, or easier to manage from a configuration kind of standpoint. You don't have to make sure that you have the correct routes between the two buildings. You don't have to, you maybe not necessarily adding another router or additional failure point in between. You just have, switch A in building A. It's got a fiber right to switch B in building B, and everybody's in the same broadcast domain. Everybody gets the same IP. Devices in building A can communicate to devices in building B, devices and vice versa. So say, you had you had a computer or a user in building A needed to print something off for somebody in building B, you could connect to that printer and print. There's a couple downsides to it, is that everything in both buildings can see everything else. You have one giant broadcast domain. So if I hopped in one of these buildings and started scanning the network with the tool, I would be able to see everything. So that can lead to it being less secure, depending on your scenario. The other thing that could happen is that if, say, you don't have a gig fiber, say you have a 50 megabit. I've worked with customers that they don't have a gig connection at all. They had 25 megabit between the two buildings. If you're running at 25 megabit, all of a sudden that broadcast traffic starts chewing through your bandwidth, and you can start reducing the efficiency of your link. And broadcast, just kind of a primer on broadcast traffic. Broadcast traffic is pretty much anything that has one source to multiple destinations. So one that happens pretty much all the time if you actually do sniff a network is that you'll see ARP requests, and that's address resolution protocol. And if you listen in, you'll see who has this IP. So who has 192.168.1.10. That will get broadcast out everywhere. That packet will have your MAC address in. The person that has, or the device that has that IP, will then send a direct unicast packet back to your device that says, I am here, here's me, I am this IP, here's my MAC address. And then those two devices will communicate directly instead of broadcasting. But if you do listen onto that, ARP tables do time out. So they do, your table is constantly getting refreshed, etc. Switches have them, routers have them, any network device has them. So even with no traffic going anywhere, even if you have multiple devices plugged into your network, as long as they have IPs, you're going to see ARP traffic, IPv4 concepts. So that traffic like that starts to add up, especially you have hundreds to thousands of devices. So across two buildings, if you have a slower link, that broadcast traffic actually starts causing problems. Typically at a faster 1 gig link, it might not necessarily be problems, but it can be a little secure, or a little less secure. And then again, kind of touching base back on that Wi-Fi problem I was talking about. You could have kind of one of those dumb switches out there causing that loop in building B, and all of a sudden you can't communicate to anything in building A. And you're searching all the way through building A for your problem, but it could be at building B. And so it just makes it a little harder to manage sometimes. Simplifies configuring, maybe less devices, a little cheaper to do, but sometimes can cause some problems. Okay, so if we kind of switch over to the layer 3 example here, instead of having our connections between the switches, we have them on the routers. And what that does is that allows us to isolate the two buildings. Broadcast, there's two separate broadcast domains. Everything on building A can communicate to building A. Anything on building B communicate to building B. And depending how you have your router set up, they might just be able to get to the internet. So you can secure them with your ACLs, your firewall filters, your rules on your routers. You could say, say you only have Active Directory servers at building A, or DNS servers at building A, and you don't have any servers at building B. Well, building B needs to be able to communicate to those servers to authenticate and to get to the internet. So you would have a rule in both the well, you could actually simplify it and just put the rule in building A and say, hey, these devices can communicate directly to these IPs, otherwise it's blocked. And if there's not a local destination, you can route to the firewall and get to the internet. So it does isolate the two buildings. And so if you do have that loop in building B, like I was saying, that loop, and you don't have any other protections in place, that loop is only going to take down building B. It's not going to take down building A, just because the router will isolate the traffic to that building. So it can, and since it is isolating, if I went into building B and I did just a basic scan of your network, I would only see devices on building B. I would see that there's a gateway, there's a route in the router, and I could use that to try to get into building A. But again, at building A or at building B, I can put in rules on the router that doesn't allow me to do that. You can go one step further and you can put a firewall in both of those places, and you can do intrusion detection on top of that, on top of basic firewall rules and ACLs. So you can add more protection. Downside is now you got to configure more devices. But again, kind of going back to the simplistic scenario there, I would want to configure it to be as simplistic as possible. So one thing I can do, and I use us as an example, is that you can use, to simplify things, you can use OSPF, which is a dynamic routing protocol, and that allows routers to communicate to each other and learn of their own routes. So a real basic example of that is that our switches at Bytespeed route everything internally, and then our firewall routes everything to the internet. Instead of putting in static routes, telling where the routers, where this subnet is, 192.168.10.0/24 is behind router A, 192.168.11.0/24 is behind router B. That firewall here in this example is going to need to know where to go. So you could statically assign it and say, hey, this is where it's at. And you would have your own routing network. That's all fine. You can statically assign and do it, but that can add some complexity and make it a little harder to manage, because you could put one route in that could pretty much break everything anywhere. So to kind of simplify that, you can use routing protocols. The first one was RIP. There's a at least 2 versions of it, if I recall. That one's pretty basic. It can do what you need to do. I've used it before. You can get into more advanced routing protocols. OSPF is kind of internal one. Ones that you'll see might hear used on the internet are BGP. That pretty much the internet runs on BGP, but they all pretty much do the same basic thing, same basic concept. They allow routers to discuss and share routes between the two. So kind of back to what happens at byte speed. So our everything internal is routed on our switches. Instead of putting 20 different routes into our firewall, I have our firewall import the routing table from our switches, and I control what is exported out of our switches, and then the firewall or our switches import the routing table from our firewall, and again I can control that by the firewall. So I'm not exporting necessarily everything. I can export only what I want, and then when you do dynamic routing, you can actually tell it to import only certain things. So even if our firewall was exporting a bunch of other junk routes, I can tell our switches and say, hey, only import these ones. So basically they communicate the 20 different VLANs that we have at byte speed. The routes are exported to the firewall. That firewall now all of a sudden knows how to get to the networks behind our switch. And then our firewall exports a default route to our switch. Our switch then learns how to basically get to the internet. If I don't have a route and I don't know where to go, I have a default route or a default gateway. If you're looking at Windows machines on their network cards, that says, hey, send this packet to this router. This router will then try to send the packet to the next destination and finally make it to where it needs to go with the default route. So that's a pretty simple example. It allows me to add and remove different networks as needed, and the firewall just learns of them. I recently made a change where I added a new kind of test bed network so I can isolate it. Within, I think, default time is like 2 or 3 seconds. Don't quote me on that. I'd have to go look at the OSPF timeouts again. But within like by the time I was actually plugging in a computer into that network and making sure I was getting an IP address, I could get to the internet once I got that IP address. I didn't have to go and reconfigure anything in the firewall. So like I was saying, you can use dynamic routing between the 2 routers here to learn of each other and learn of the networks behind. So you can use some of those layer 3 technologies to kind of simplify some of your networking. Do I necessarily need that at byte speed? No, I don't change my network. I'm not adding different networks as often. I think it was probably the first one I've done in probably a year and a half. So I could statically assign it. So if you got a simple network, static routes and everything, totally fine. But you can use dynamic routing to kind of simplify some of that stuff. Okay, so kind of talking about VLANs again. If you recall, I like to think that they're, I have my core switches here. I have a guest VLAN, virtual LAN. I have a data VLAN, and then I have maybe a management VLAN. In visualization, you can think of it as separate switches, and we have a router that connects them all together. It's just instead of having physical separate switches and physical separate devices doing that, we have them all in one layer 3 switch, and it internally those that ports are on certain VLANs. I can tag traffic, and that allows me to kind of more efficiently use the resources. I don't have to pay for multiple different switches for power. I don't have to add additional cooling for my server room or my switching closet. because I'm all doing it on one set of switches, one stack of switches. You can doing this, isolating devices and stuff, also can increase your security. So like the big one that you'll see a lot of places, have a guest Wi-Fi. Obviously, you don't want that accessing your core network or your data network or any of your data or your servers, whatever it be. You don't want that there. You just have that guest Wi-Fi so people can hop on, take their cell phones, hop on to your guest Wi-Fi and get to the internet, while they're waiting for something. That you can use, again, these VLANs and routing and access control lists and firewall filters to isolate that traffic to that specific VLAN. So again, you don't need multiple switches to do that. You can do that all on a layer 3 switch that does that routing. And it does allow you to use or be a little more efficient on your resources. So pretty basic example here. We got 4 VLANs. And again, VLAN IDs are 1 through 4096. We have an accounting VLAN, a guest network, an Apple TV/chatty traffic, and pretty much everything else. So just kind of like a data VLAN. To become part of becoming PCI compliance, and I'm not an expert on this, I just know, I know enough to be dangerous. If you're processing cards, they are supposed to be on an access controlled VLAN that is separate from your other traffic, pretty much so you can filter it with your firewall rules, your ACLs. So maybe we have an accounting VLAN and we have servers or devices on that accounting VLAN that only people in accounting or management have access to. I can control that by plugging in devices into those access ports, or if I'm connecting between different switches, different stacks, I have a trunk port that allows that tagged traffic to go from VLAN 10 across that trunk connection between my 2 switches. Again, I touched on the guest network earlier. Strictly for people, so they're coming in, we're waiting for, at a dentist's office or something, or waiting for a meeting of some sort. They can hop on a guest network. It might be open, might not have a password, might just have a captive portal that says something along the lines of you agree to the terms and conditions, you hit yes, and boom, you're on the internet, right? Again, don't want that, a guest device that you may not necessarily control, hop on your normal network. So they're isolated to VLAN 20 on the guest network, and they're only allowed to go to the firewall. VLAN 30, we have Apple TV. They're pretty chatty, broadcasty, and you could put devices on the VLAN 30 to kind of isolate it. And depending on how you set it up, you can actually reduce the where those broadcasts are actually going. You can rate control on VLANs with some of those ACLs and filters, and then we have everybody else. So normal computers plug into VLAN 40. Servers that may not necessarily need to be as secure as accounting servers, stuff like that plugs into VLAN and VLAN 40. And then we got our switches routing in between them. We got our rules in place that allow or disallow traffic. And if devices need to get to the internet, the layer 3 switch, the routes to our firewall. Firewall goes through the internet and protects us from the internet. Okay, so I kind of already touched on this. Access ports receives untagged packets, and they literally take that traffic, dump it into the VLAN that you put it on. So I have a computer. If we go back to this example here, I have a computer. My accountant Ryan needs access to that accounting VLAN. I take his computer, plug it into port 20. I then configure that port to go on the accounting VLAN. Again, it will take traffic that's untagged, put in that VLAN, and anything else on that access port is dropped. Trunk ports can receive untagged and tagged traffic. If you kind of going back to that voice phone example, it would be a trunk port. I can receive untagged packets from my computer and tag packets on my phone. And the switch will then put them in the correct VLANs and switch and route as needed. And then another use that trunk port is used for is depending on, or not depending, but trunk ports can be used between different switch stacks. So, you know, if you have a big enough building, there is a limit to how long your copper Ethernet can go. So you might have one or two different switching closets. You'll have a core and maybe two edge switching closets, and you might have fiber connected up between the two. You'd use a trunk port because most likely you're going to have a VLAN that traverses to multiple different switches. You can use that trunk port to make sure that multiple VLANs and the traffic between multiple VLANs are switched between two different switches or switching stacks. So that's another big use for trunk ports. Then some switches have advanced, kind of more quote unquote advanced features. Mac-based VLAN, VoIP VLAN, camera VLANs, third-party VLANs, and pretty much what they do is, you know, the county I'm working with has HP switches. It has a VoIP VLAN, and pretty much that is just a pre-configured Mac-based VLAN where we know, say, Cisco switches or Yealink switches, or sorry, Cisco phones or Yealink phones, Mitel phones, they all start with the first part of the MAC address is going to be similar or the same. And it basically takes that MAC address and says, oh, I see this MAC address, this goes into this VLAN. You don't have to configure a VLAN for that because it's auto configured. You don't have to configure trunk ports for that. They just kind of work. They can be handy. I personally kind of pre-configure all that stuff. The phones that I work with, you can use what's called a LLDP media packet, where your switch basically tells the phone what VLAN to go on. So I choose to use that over Mac-based VLANs. But if you do have a switch that has that capability and it doesn't have the LLDP media capability, it's certainly a good solution. Camera VLANs, you know, kind of similar concept. The MAC addresses of particular cameras, the first half of it's going to be same, depending on the manufacturer, and then we know that we can take the traffic from those VLANs, or traffic from those cameras, dump it into camera VLAN, you know, or necessarily the camera server needs to get access to the cameras, but nobody else. All right, so kind of brief on security. Pretty much anything that you could do virtually, whether, you know, VLANs, firewall, filters, access control lists, etc., is pretty much useless if you don't have physical security. So if you have a switch or a couple switches just sitting out there in a room, and people are able to just kind of go in and plug into it, it's pretty pointless. Even if you go and shut those ports off, you're gonna have to some way be able to manage it. And you know, if you shut those ports off, you can go unplug it. You can do some security with radius, but that adds complexity to your network. So pretty much, if you don't have physical security, everything else is kind of useless. But with that said, if you do use VLANs and everything, you can control access to that information. So, for example, you know, on my guest network here, I'm going to be blocked to my accounting network. My rules say that I don't want traffic from my guest network going to accounting, but I can allow that traffic to go to the internet. So to kind of go through an example here. Again, I'm Juniper certified. I'm more familiar with Juniper. I know enough to be dangerous to convert configs from other manufacturers to Juniper. So we're going to use Juniper here in our example, but that doesn't mean that, you know, other switches can't do that. Pretty much every other manufacturer that I know uses access control lists. Juniper calls them firewall filters. In the Juniper world, it goes from top to bottom, and it kind of follows an if-then scenario. That it does go from then. In my mind, it's if-then, because you know, you can do if the source is this or the destination is this, then discard, accepts, log, stuff like that. But it is a little kind of from. Let's see if I can. So with Juniper, you can do what's called a prefix list here. It allows you to group, say, different subnets or IPs together, and use that to write one rule instead of multiple rules. So in this term, in this firewall rule here, we have a trusted LAN prefix list, and so that's all of our networks that we trust, and we want to, on our guest network, we want to deny traffic from our or spoofed traffic from our guest network. So that would mean, you know, I come on wireless or wired, I then go statically assign an IP on my device instead of accepting whatever the network is handing out. And I'm trying to spoof that traffic. So depending on the router and how it's configured, if it sees spoofed traffic, it could route it. There are settings to disable this, and if you're on a firewall, generally that kind of just doesn't happen. But if you're on just a kind of router, this is sometimes good to have. So this is kind of going from top to bottom. We got our filter guest block here. The first term is denied spoof. Again, denied spoof can be a name for anything. As you can see, there's term 0 and 1 beyond it. We have from, so again, kind of that if statement there. So if the source is from our trusted trusted LAN, so trusted prefix, source prefix, trusted LAN. If it's any of the subnets, you know, from our trusted LAN on the left there, then we're going to just immediately discard it. We don't have to necessarily log it, but we could log it if you want. We can count it, etc., stuff like that. But mainly this is just denying spoof. So say we have our next term, so that would be processed in the list, would be term 0, because we're going top to bottom. If the source address is 10.0.20.2 and the destination prefix list is backup 2, which is, say, just a backup server, and we want our backup server to be able to communicate to this server on 20.2, say that's just a basic DNS DHCP server, just so people have access to it to get to the resolve the internet, etc. And so we want to back that up. We would then write this rule. So source address is the 20.2, destination is backup 2, and then we accept the traffic and we allow that traffic to go through. Say term 1, we also have, you know, say it's for you have your employees or your staff or students, etc. stuff. You know, you encourage them to use your guest network for their cell phones because they don't need access to the rest of your infrastructure. but you say you host your own mail servers. So we can do the whole guest network here at 10.0.20/24. Destination, again, we're using prefix list, mail servers. We could just put a destination address of an IP or a subnet. But then we can also add what port we're using. So term 1 was basically if it's from the guest network, which is 10.0.20.0/24, the destination is our mail servers and it's HTTPS, then we accept. This term would not allow other traffic to our mail servers. So if I was trying to go port 80 for HTTP, if I was trying to ping the device, do an NS lookup at it, pretty much literally any other port, it would block it. Or this, it wouldn't necessarily block it, but this term in our rule would not allow it. Let me see if I can clear that. Okay. So kind of continuing down along the rule list here, we have another server called DA, also runs on HTTPS. We want people to allow to get to that. Then we, from our guest network, then we accept it. And then finally, term 2 is our rule that blocks it to our trusted LAN again. So if you recall, the first one is spoofed. This one is non-spoofed. So this one, I take my laptop, I connect to Wi-Fi, I get an address from the network. I try to get to my trusted network. We're going to discard it with the then discard in term 2 instead of a then accept. On rules, usually you can do a discard or reject. A discard silently drops the packet at the switch level or the router level or the firewall level. A reject actually sends a response back to your device that says that is not accessible. You could do either or depending on the purpose of the rule. And then most rules have an implicit discard or reject. So term 3 is to reject the rule. So, for example, if we're going to Google, we get the router gets a packet that is destined to Google. So first it starts at the top of the list. It goes, hey, is this source prefix of our trusted LAN? No. So then it goes to term 0. Is the source address specific to 20.2? No. So then it goes to term 1. Source address is 20.0/24. So, okay, yeah, now we're in the subnet. Destination, we look at the destination now. Destination is not the mail servers. So then we skip out of term 1. We continue into term allow DA. Again, we match on the source address. We don't match on the destination address. We skip then to term 2. Again, match on the source address, don't on the destination address. And then finally, term 3 is just a default accept. So we hit the internet. If we're going through spoofed, we're spoofing our address, we're blocked right away. If we're on, we get a normal network address and we're trying to get to our trusted VLANs, we are blocked at term 2. And this rule is basically put at the inbound on either your virtual interface or your physical interface of the guest network. So again, kind of going back to this quick graph, we can use the rules to block access to different parts of our network, whether that is strictly a guest network. That's a lot, it can be, it doesn't have to necessarily be a guest network. It can be however you want. Again, I just recommend it being kind of simple, easy to manage. With that said, to try to simplify management of switches. One thing to do is you can stack them. And so what stacking is you take multiple different switches and you connect them up in a way that they realize they realize that they're supposed to be in a stack and they are managed by one management point. A lot of switches nowadays will have dedicated stacking ports. So basically you take more than one switch, plug in those stacking ports, the switches will go, okay, I'm supposed to be in a stack, and they will form, and then you can configure all those switches from the same either command line, web GUI, the same management points. It does also improve your network, because then pretty much kind of going back to that spanning tree, you have a base bridge, which is typically near the edge of your network, right next to the internet, or like the core of your network, and not necessarily next to the internet, but basically your core of your network. If you do stack those switches, all that those say we stack 3 switches, those 3 switches there are all the same spanning tree root bridge. So you don't have your spanning tree could converge faster if you're stacking your switches. But big thing is in my mind is network management. Juniper, the main switches that we use can stack up to 11 in one point. So you can get, that's what, over 500 ports of density that you can control via one management point. And that makes it a lot simpler, a little easier to make, or a little less, it reduces errors because you're not making multiple configuration changes to different switches. And then it also simplifies management. An example I like to use is that I was working with a school. We were implementing new wireless access points, and with that install, we were adding a couple different wireless VLANs. One of them was a guest network. This person's switches were not stacked. They're all individual switches. And they had just recently upgraded. And so what I had to do to find all the access points, and to be honest, I think I did a pretty good job. And it seems like every access point showed up in the controller. And as far as I'm aware, the guest network made it everywhere. But since it was individual switches, I had to trace basically go into the core switch, see where these access points were plugged into, see on what ports they were, and then eventually I'd hit a port that is connected into another switch. So then I'd have to get into that switch, do the same process. I'm looking for access points. Okay, so I see access points are on these ports, but then I see 7 of them on another port. So then that is clearly connected into another switch, and I have to go into that switch and kind of do the whole process over. And so I basically went top to down in their network and to find these switches. Now, if they were all stacked and we had multiple switches in the same switching closet stacked, I can view all the access points connected into all 3 switches all at once. And then I can see that, okay, so maybe there's 10 access points on this port, and I can use this switch to figure out what switch that is connected to. I then go to that second switch and say that one is a stack of 3 switches again. Okay, so that's got 20 access points on it. So it just simplifies some of that management stuff, where I can go in and add that guest VLAN across multiple ports, across multiple switches once. I don't have to go into 3 individual switches, configure that VLAN, add it to that switch, and then add it to those ports. I can just configure that VLAN. I can add it to multiple ports across 3 different switches at once. So that's the example I like to use with stacking. And then it also adds or benefits on some loop detection as well. With that said, there are some management software out there These are kind of first party. There are third party software out there as well. And basically they give you kind of a single pane of glass across your network. For the Juniper world is Junospace. Network Director is the one that allows you to take all of your switches everywhere and kind of control them all at once. If you want to deploy your guest VLAN across all those switches, you could do that with, with Network Director with 4 or 5 clicks, and then it just deploys it everywhere instead of doing 15 or 10 or 15 different closets. So it can simplify that. Kind of a neat thing with some of this network management software in the Juno space, Security Director can actually work with your firewall, and say your firewall detects that your a computer is sending out spam, or it has a virus and is trying to connect to phishing servers, you name it, it detects something wrong with that computer, and it can actually work together and shut that computer off from your network. It can isolate it completely. So there's a couple cool things you can do with that. Third parties there kind of do, as far as, and I'm not an expert on all of the third party ones, but they do allow for easier network control. And some of them, and a lot of first parties are coming out now with this too. So Ruckus started out as a wireless company. They were merged into a couple different, into Brocade, and now they have switches. So in the cloud and on their smart zone controllers, you can view your wired and wireless network from a single pane of glass. So there are software out there to simplify management. It's certainly an option for you. Certain things like Junospacer and its additional add-on cost, additional add-on licensing. You don't necessarily need to do that if you're comfortable with the CLI and the web GUI and doing it at different points. For example, the Ruckus Smart Zone, you're going to have a controller of your access points at some way, so you can add an additional license and control your Ruckus switches if you're interested. But that's pretty much it. I don't have anything else. If you have any questions, feel free to email us and me. I think my email was on the email blast out there. If not, I'm on our bytespeed.com/about, pretty much his first initial last name at bytespeed.com. So you can just email me at abenson@bytespeed.com. If you got any questions, definitely shoot them my way. Yeah, I guess I'll just let everyone go and hope everybody stays safe and have a good Thursday.